Yes, the important transfer of heat are number one, conduction. Conduction is the process of transfer of heat from one particles or one molecules of the body to next and then to the next and so on without actual movement of the particles from one place to other place. Particles only vibrate about their mean position and during vibration they keep on transferring the energy from one particle to other particle. So conduction is the process of transfer of heat inside a solid object and we can define it in terms of the vibration of the particles about their mean position and during vibration they collide each other. They pass on the energy from one particle to other particles and they just start to vibrate about their one mean point. So this is the most important method of transfer of heat in the solid and in this very conduction there is only energy is transferred but there is no actual movement of the particle. You should take care of. We can show this conduction by an activity also. You can draw the diagram of activity of the conduction. You make a diagram of the conduction process. You see here. Also, you just take a solid object. Take a solid object, iron rod. You take a metal rod. Take a metal rod. Yes. This metal rod coated with a thick layer of wax. This rod is placed over the two metal stand. To make it stand here. So metal rod is put over the stand. What happens then? With the help of suitable spatula, rod may be used for some small buttons are fixed over it on the wax. So putting of wax, some buttons are you can see here small buttons. Small buttons are pasted on or fixed on the wax at regular interval. The distance between the one button to the other is taken 5 centimeter each, and this wax is allowed to solidify and harden up. This metal rod, when placed over the metal stand, on which the metal rod is kept, and you can also see here this rod is in the rod so that yes, This rod is the one end of the rod. We make an arrangement of flame. Yes. Flame of the burner. This is the simplest activity. You can see in the diagram here, when some small buttons are fixed on the wax layer of the metal rod at regular intervals of the distances, and when the wax solidify and harden up, the button is fixed into it. And this rod, when placed over the stand, and when the rod is heated to the one the rod is heated, one end of the rod is heated, one end of the rod is heated. After some times, we see that, we observe that buttons start falling down. Buttons start falling down. This button is now falling down. When heat is supplied from this side, where the one end of the rod is heated, it is observed that small buttons are start falling down. Small buttons start falling down. Why does the button falls? What is the reason why the button is falling when we are eating? This button falls one by one. One by one. It means it must be transferred. Why the small buttons are falling? It is falling due to the heat supplied and melting the wax. Due to the heat of the burner or the flame of the burner, the heat is transferred. Temperature of that end also increases. When temperature of the one end increases, what happens then? The particles of the rod just start to vibrate inside its material, and just due to vibration about their mean position, they start to transfer their energy from one particle to other particle inside the metal rod. And due to that, when temperature of that is gradually increasing due to the continuous supply of heat, the buttons are falling down one by one. So this is a very simple activity of the conduction. This falling of the button shows that there is transfer of heat through the solid material, metal rod, and subsequently melting of the wax on which the buttons are pasted. When temperature of the rod increases, the wax start to melt and the button pasted on it just start to fall down. So it is seen gradually falling of the buttons. so that there is gradual transfer of energy, heat energy from one end to the other end. Now let us see whether the heat energy is able to go along easily through all solids. If it is a metal rod, heat can transfer. But when we put one end of the metal rod in a flame, and its other end also soon becomes hot, too much hot, means all whole amount of heat energy is transferred from the one end to the other end. So this shows that heat goes quickly along a metal rod. So we say that metals are a good conductors of it. What is the conclusion of this activity? Metals are metals are good conductor of heat. Metals are good conductor of heat. So you can see here metals are the good conductor of heat. Okay. On doing the same experiment with a wooden rod, when you are taking wooden rod, then you will find that the end of the wooden rod held by us does not become hot even after a long time. When in place of metal rod, when wood is used, it is not heated for the long time, and they start to burn. If wooden rod is used in place of this metal rod, the wood will start burning. This shows that heat cannot easily go along a wooden stick. So wood is a bad conductor of heat. Wood is a bad conductor of heat. It starts burning and not transferring the heat from one end to the other end. So it is called bad conductor. Bad conductors of heat are also called insulator. Bad conductors of heat are also called insulator. Yes, insulator you can also pronounce. All metals are good conductor. Okay. It can transfer the heat better from one end to the other end. But insulators does not allow the heat to flow. So what are the insulators or poor conductor of heat? You can note down this also. Wood is one of the example. Wood is one of the example of the insulator. Similarly, you can note down ebonite, and cotton, plastic, for these are the name. Thermocol, air, and water. Air and water. So take all these examples of the bad or poor conductor of heat. These are called heat insulators. All are called heat insulator. Heat insulator. Okay, these are all called heat insulators. So by the method of conduction we have seen. There are so many examples in day-to-day life you can think of. Number one, We use metals to make cooking utensils. Metals, being a good conductors of heat, it quickly transfers the heat energy of the flame to the food items kept inside, and the food items then get heated up and cooked. So metals are also used for making kettles, boilers, and boiler tubes due to the good conductor of heat. Okay. The number second examples are which are we use wooden or plastic handles for holding tea kettles or cooking utensils. The handles help us to hold them even when the objects themselves are quite hard because being insulators, they do not let the heat to flow or get transferred out to our hands. Similarly, third examples of the conduction is here. Use of bricks and mud for making houses. Wood, bricks and mud help us to shield us from the heat of the sun during summer. These materials are bad conductors of heat and hence do not let the outside heat to reach inside easily the house. So we can now also understand why rooms with tin roofs and often becomes very hot during summer. Tin is made up of metal and so it allows the sun heat and enters into the room and makes the room hotter. But when the house is made up of bricks and mud, they do not allow the outside heat to enter into the room and we can feel comfort during summer days when the houses are made up of bricks and mud. Here, the another examples of the heat insulator. Here is meant to be the bad conductor of heat, blankets, woolen cloths, and quilts. Blanket, woolen cloths, and quilts help us to stay warmer in winter. All make use of bad conductivity of air. They trap the layer of air between themselves and our body. So, trapping of air is much better in the neutral than in the old one. Our body heat does not easily escape out through these trapped air layers and stay our body warm. So why neutral does giving more warmer to our body? Because of the reason that the neutral having air is trapped inside it and they do not allow the heat of the body to go out and we can feel warmer during the winter season. You take another example, ice boxes are often made as a double wall containers. The layer of air trapped between the two walls and does not easily let the outside heat reach the ice and kept inside the box. The ice does not melt quickly. So ice box also keep the ice cubes in the ice form in the solid state and it is kept inside the double wall containers because inside it air is trapped and they do not allow the heat to go out. So ice does not melt and we can use it. Now the second mode of transfer of you can see here. Second mode of transfer is convection. Convection. We notice that water is a poor conductor of heat. No doubt. Then how does then the water put in kettle get heated up when it is put over a flame? The molecules in the liquids or in the gaseous state are quite free to move. So in this method, in this mode of transfer, of heat, particles or molecules are free to move from one point to another, and heat is transferred. Heat is transferred from one particle to other, one particle to other. So the method of transfer of heat, due to the actual movement of the particles, the energy is transferred from one particle to the other particles. The molecules which are very near to the heat flame, the molecules which are very near to the heat flame are getting hot and lighter and rising up. So we call this method as a convection. How convection helps us to transfer the heat? We can once again take another activity. In that activity, we can see how the convection heated up all the molecules. You just think, you take a round bottom flask. You take a round bottom flask. You take a round bottom flask here, and yes, now you place it over the 3-point stand, provided this is ball. Okay, the balls here. Yes, the wire gauze is placed over the 3-point stand. This is the stand. Making gas burner here. Put water in the round bottom glass. Yes, the water inside it. You can see here how the, yes, let's see. When we take a round bottom flask and it is fitted in the stand, and we take a 3-point stand. 3-point stand is this. 3-point stand. Wire gauze. Round bottom flask. Round bottom flask. These are all taken. And in the wire gauze, place over the top of the 3-point stand, flask is kept over it, over the wire gauze, and flask is filled with water. Half part of it is filled, and some crystal of potassium permanganate. Water plus crystal of potassium permanganate chemical is kept inside, mixed with the water. Potassium permanganate, when put into the water and burner is just started, we observe that a streak of color moving up. the strip of color moving up like this. Yes, this is called conventional current of water. When the water is heated, the water is start to rise up. Water start to rise up from the end which is very near to the flame, and the colorful water is circling, rising up, then falling down. The hotter molecules start rising up and colder ones falling down. Becoming hot, then once again they circulate. In this way, convectional current started and makes all the molecules hotter and hotter. So we see here by the cyclic movement of the color strip in water. Water at the bottom of the flask gets heated up fast, and as a result, it becomes lighter. Hot molecules becomes lighter, and as the water molecules is free to move, so these heated up lighter molecules or color in contact with the potassium permanganate crystal move up, and the colder one, heavier molecules at the top falls down or move down to take the place vacated by the molecules. So this movement of the hotter molecules in the upward direction and colder, heavier falling down inside the round bottle flask, producing the convectional current. And in this way, cyclic movement of the water molecules make the molecules hot. So we can see here such type of the transfer of heat is called convection. So all liquid molecules, especially as well as the gaseous molecules, are heated up due to the convection method of transfer of heat. We make considerable use of convection current in our daily life also. The use of windows and ventilators in the room, use of chimneys in the factories, and the radiators in cars are some common application of the method of convection current. So take care of the use of windows and ventilators in the rooms and use of chimneys in the factories and radiators in cars are common application that are based on convection current. Convection current also have a significant effect on weather also and climate also. When the air at a place gets heated up, it expands and occupies more space, and it therefore becomes lighter and moves up. The air pressure at that place then gets lower, and hence air from the surrounding places rushes to take the vacated place. So this setups a convectional current of air and giving forming winds and the storms. So winds and storms are also created in nature due to the convection currents of air. So these are very, very day-to-day natural events observed by wind blows. The blowing of winds is caused due to the temperature difference of the earth's surface. And wherever the temperature is high, the air molecules becomes hot and they becomes lighter, they rise down, and the upper side here are heavier, they fall down and coming down, take the place which has been vacated by the light. So the colder air comes down, hotter air, lighter air rises up and makes a conventional current in nature and blows the winds. And storms are also created due to the sudden change of temperature of the earth. The storms are also created on the surface of the earth in nature due to the convection current. Okay, children, we have seen here today two activities and the conduction method and the convection method. These two you will learn and revise, and next time we will once again take Okay.